2, I think. So, about logarithms.
Wait,
Uh-huh.
continue.
Uh, okay. So logarithms. We already know how exponentials work, right? An exponential is essentially a number with a variable on its power, right? A logarithm is essentially the inverse of exponential. This is the opposite. Now, it's really hard to understand in the beginning, but I have a way that, sticks very quickly. So a logarithm has a bunch of components to it. The first one is the base, let's say a, for instance. And then you have the argument, I guess you could call it, b, and then it equals something. Okay. The way you should look at a logarithm is this essentially is simply saying a raised to the power of c equals b. That's all. Okay.
Okay.
So now, if for example, if I ask you to fill in the blank in this question, what would I put here?
You would put 16, no?
Exactly, because 4 to the power of 2 is 16. And if I say, for instance, fill in the gap this time, what would you say is here?
3?
Exactly. And if I say fill in the gap in this case, what would you say?
2.
Exactly, because 5 squared is 25. That's literally it. That's how logarithms work in general. Okay? It's like 4 to the power of 2 is 16, 3 squared is 9, 5 squared is 25. Okay,
Yeah.
that's simple enough. However, you never really get asked, what is the log, like just to find the value, because that would be too easy for AA. So what really happens is you need to use some, so there's a variable in the log essentially, and you have to kind of work with that. For that, we need to talk about rules of logarithms. Very unoriginal name, but bear with it. So the first thing is that if you have two logarithms, all of these rules, by the way, apply to logarithms that have the same base. Just like last time in exponents, we used to say that the exponentials must have the same base, right? 2 to the power of x times 2 to the power of y will add up because they are the same base. Similarly, in logarithms, you must have the same bases for all of these rules to apply. So let's say that the base is a in this case and the argument is x, and here the base is a and the argument is y. If you have two logarithms adding, you can combine them by multiplying the insides, which is exactly the opposite of exponentials, by the way. In
Yeah.
exponentials, if you have two exponentials multiplying, you can add their powers, and this is the opposite. Similarly, if you have two logarithms,
Subtracting, it's division, right?
yep, let's quickly write that down. And then, what if, this is going to be, by the way, one of the most important rules, if not the most important. If you have a log, any base, whatever, and you have like x to the power of 3, or x to the power of b, let's say, to make it general, you can pull the power of the argument out and put it up front. Okay? This is going to be
Okay.
extremely important. I'm spoiling it for you, but this is going to be the most important thing in a bit. Got it? By the
Got
way,
it.
it works vice versa too. You can pull it back in as a power.
Okay.
Okay? Um, and I think that's essentially it. I mean, there are some like notes, I guess, or interesting cases that you should also be kind of familiar with. The cases are, for instance, if you have log base a of itself, what do you think this should equal?
1?
1. One very important thing is that if you take a log of base b and whatever, right, and you raise it to the power of b, okay, what should this be equal to is the question.
Hmm. I'm not sure.
So let's try to think about this, right? It's almost like a riddle. B to the power of something equals a, okay? So there is
Yeah.
something out there such that when I raise b to that number, it becomes a. This will give me that number, correct?
Yeah.
So if I raise b back to that number, what should I get? A. Weird, right? Let's use actual numbers. 3 to the
Yeah.
power 3 to the power of log base 3 of 9. Let's talk about this guy first. 3 to the power of
Okay.
what is 9?
2.
2, which means that this is equivalent to log 3 to the power of 2, which will give you 9. Because first you asked me, how do I get 9 from 3? I told you, and then you raised 3 to that.
Yeah.
So of course you're gonna get whatever you asked me would become, like I don't know how to even say it in English, but essentially to make it easy, this cancels out with that and gives you A.
Okay.
That's the way you can remember it. Okay? The idea behind it is so weird and riddled that it's hard to understand. But essentially, oh God, it's back. Pressed undo a bit too much. So it just gives you A back. Go, what is happening? So this is also going to be very important that, an exponentiation cancels a logarithm. Okay? So raising
Okay.
a logarithm to the same base as a power will cancel out that log completely. This all will also be our saving grace. So remember that these two things are super, super important for something we will see in a bit.
Wait, I'm a bit confused.
What's up
Um,
about
what do you
this?
mean like raising it? Yeah, this part.
Good question.
Raising it.
That's a great question. So let's look at an example of it. For instance, if you have 3 to the power of x, oh no, sorry, that's an exponential. If you have log base 3 of something equals 10, for instance, how do I solve this equation? I mean, since we already know how, logs work, we could say that this is the equivalent of 3 to the power of 10 is equal to x
Yeah.
and just get it over with. However, what if I wanted to be a bit fancy and, do it in a actual complete way? We would need to remove this log somehow, right?
Hmm.
Because, for example, if this was a sine, I would remove the sine by using the special function sine inverse. What is the inverse of a log? In the very beginning, I said that the inverse of a log is exponentials. But how does that apply? Like, how do you use them? Sine inverse, you just apply it. How do you use the idea that an exponential is the opposite or the inverse of a log to solve this, to cancel this out? You basically raise both sides of the equation as a power of 3. Okay?
Okay.
Why did I do that? Because of this rule. If you raise a log with a certain base to the power of that same base as a number, you will cancel out the log completely, and this guy is going to drop. So basically, 3 cancels out log 3 and gives you just x.
Ooh, okay. I
Yeah,
understand now.
that's the idea. So we're going to see more examples of this in a bit, though. Don't worry. So this is, by the way, we've begun the examples. That's all we need to know about logs before we can start solving some problems.
Yep.
So I just want to clarify something about the natural log. So my brother and I, when we were younger, he was teaching me about natural logs, and we got into an argument because
Hmm.
I wanted to call natural logs log base e, and he said write them as natural log ln, and I said they're the same thing. They are the same thing, and I will always die on that hill. But we have to write natural log. It's just a convention, okay? ln is
Okay.
essentially just a regular log with a base of e. Remember, e is just a number, okay? 2.713 something. It's something like that. Okay.
All right.
So natural log works the exact same way as other logs is just that a special log with a base of e. The reason we have a separate name for it, the French chose this, by the way. That's why it's the other way around, which is weird. But the reason we have a special name for it is because, again, it shows up in natural physics and natural sciences a lot. When you start to model population growth, for instance, the E pops up all the time. That's why we gave E a special name and
Oh,
ln a special name. So it's a weird relationship that keeps showing up in the real world. So how do we solve a logarithmic equation like this? The first step to solving a logarithmic equation is to, number one, have all of your logs or all terms, every term in your equation should be a log with the same base. So we already see a problem here. The bases are not even the same. Okay.
yeah.
And this reminds me that I haven't told you about it. One more thing that you need, which is change of base. So how do you change the base of a log? So there's a formula for it. It's a pretty specific formula. It's a bit hard to remember, but I have a visual way to remember it. Um, Basically, if you have a log with any base, let's say A, and you want to change that base to B, okay? The first thing you do is write it down like this, log base B over log base B. That's the new base that we picked. We can pick literally any number, okay, for the new base. The only thing we have to do is write it in this form, put the upper thing at the top, put the lower thing at the bottom, and that's it. This is how you
Hmm.
change the base from A to B. So let me show you an example of this because that doesn't make any sense at all. So log base 3 of 5, for example, and you want to change the base to, I don't know, 4, for example. First
Yeah.
write log base 4 over log base 4, put the top thing at the top, put the bottom thing at the bottom, and that's it. Of course, it's a bit messier, but at least you change the base. And
So
why?
it becomes log base 4 5/3.
No, no, log base 4 of 5 over, you can't do that. You can only do that if they're subtracting.
Uh,
You can't divide the insides just because the whole log is dividing. This is not
so what's
equal to
the
this. It's not equal to that.
so what is it equal to?
That you gotta plug
We
that
just
into
leave
the
it in that
calculator.
form?
Yeah, you can't do anything to it. It's a mess, I know, but it's you did a big thing. You changed the base. Why is it a big
Okay.
thing?
This is a
Because
calculator question.
for sure, yeah. I mean,
Okay,
you
thank
can't do
God.
this without a calculator. I mean, yeah, you definite. I mean, you could, but I don't think this would ever show up in a non-calculator. Oh wait, let me let me check whatever it is. Um, no, it doesn't say, so it's probably yeah, it's definitely calculator. I mean, this is it's a mess. Anyways, so again, it's a mess. So why did we do it? Because of the thing that I just showed you. To solve a logarithmic equation, the basic requirement is that all the logs have the same base at least. If they don't, you can't solve it. So we need this thing to be able to change bases so that we can actually make an unsolvable equation solvable. Okay, so the problem we see is right there. What should we do? How do we change the base of this guy to something else? And what should we change it to?
So we should change it to 9, right?
Yep.
So it would be log base 9 and then wait, what am I? This looks
Yeah,
funny.
you're fine. You're fine. It looks really bad, but it's just how it is, right?
Yeah.
So this is exactly correct. Now, I can actually do this without a calculator, and you should be able to too. Let me show you why. Why are your X's so bad? That looks like brackets.
Leave me alone. I
All
like
right,
to
so
write
you
them
have
that way. It's fun.
just do it this way. It's so much cooler. Anyways, so it's basically like that and that, and you join them. Okay, sorry, I won't do that again. All right, so
No,
you
no, no,
have
wait, just try writing it like this. It's so fun.
it's okay. You know what? Not
I
bad.
saw someone write it like that and I was like, yeah, this is nice. I like this.
Oh, okay, log base 9 of 3. Okay. The thing is, this is actually a very easy thing to calculate. 9 to the power of what is 3?
But
What would you need to do to 9 to get 3? Let's start there.
I think to the power of 1/2.
Because you had to square root it, right? So this is 1 over 2 divided by 1 over 2, and that's it. No,
Yeah.
no calculator needed. Okay, here's the fun part though. You have this on the right side. But I said that all of your terms should be logs with the same base. This guy is an imposter. He's not supposed to be here, is he? He's not a log at all.
Yeah.
So what do we do about him? By the way, before we talk
Do
about
we
that,
erase it? Oh no, 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 no.
ooh, you're
No, no, no,
close.
because it's not
You're actually
multiplied. My bad.
no, you're heading somewhere in the right direction actually. Anyways, so we can do something here first. Divided by 1 over 2 essentially just means multiplied by 2,
Yeah.
right? So now let's talk about that one. Is there any way for me to say that log base 9 of something is 1? What could this be? What could I put here so that I could say 1 is the same as that?
Hmm.
So think about that thing, 9 to the power of blah blah blah. What should this be? 9 to the power of 1 is?
Oh, 9.
Exactly. And if you come back here, remember that I told you a trick. Log A of A will always be equal to 1. So you can always
Oh,
replace 1 with log 99 or log AA essentially. So 1 is in fact a log. 1 is everything.
whoa.
Yeah, divine. Okay. I mean, it is a divine number. Anyways, so you have a bunch of log bases of 9, right? Perfect. Now what? Combine all of the logs on each side. So we can combine both of these how?
Oh, multiplication.
Multiply the insides. Perfect. Now, uh, small little detail is that we cannot have coefficients with the logs, okay? So we can't have this 2 here. So what do we do about him? How do we get rid of this 2?
We erase it, right?
Perfect. So we have a pure log on the left side, we have a pure log on the right side, and nothing else. This is all cosmetic, by the way. The equation we had in the beginning has been morphed horribly to become this. Okay, but why did we do
Okay.
this? Because now we can finally cancel out the logs. There's two ways to think about it. You can either say that you're raising both sides to 9, which is, logical, which will cancel out both sides. Or you could just say that if the log base 9 of this is equivalent to log base 9 of that, then this must be equivalent to that too,
Yeah.
right? So this is the equation we get, and we can solve this very easily. At least I can. If I subtract 9x on both sides, I end up with this, and that's a quadratic equation. It's super easy to solve.
How do you
So
expand that quickly?
just a square minus 2ab plus b square. A plus b whole square is a square plus 2ab plus b square, and a
Oh,
minus b whole square is a square minus 2ab plus b square. So see, we have a minus b, right? So a square
yeah.
minus 2ab, so minus 2 times 4 times x, so minus 8x, then b square, 16. I
Oh,
mean, once you
okay.
do it a few times, it becomes easy. In the beginning, by the way, until like the university even, I used to do it the long way because I used to be very paranoid about getting something wrong in these
Yeah, that's
little cases.
exactly why I do it like expanding,
Yeah,
because I'm like,
but
oh no.
when I started teaching, finally like started doing this because it's quicker, which is pretty bad because my students are still my high school self. They should probably be a bit slower. But yeah, with people who I know can do this, then you know how to do this, right? Expand it like
Yeah,
manually.
of course.
So that's why I just do it because I don't want to spend time explaining that to you. You already know it.
Yeah.
Anyway, so we end up with this quadratic. You solve it, whatever method you want, and that's basically it. Now, what's the key? Key was two things. We need to end up with a pure log on the left, a single pure log, and a single pure log on the right side, which means that we need to convert both of these to the same base. Okay. Secondly, we need to write down 1 as a log also with that same base. Where is that all going? What happened? Okay.
I didn't mean
So
to click it.
you dragged it away from its whole family though. Okay. Let me
I
put it
didn't mean
back
to.
there. Okay, so that was the key. And then once you have a single log on the left and the right, you can just cancel them out or say that you're raising them both as powers of 9 and then cancel them out, whatever. And that's basically it. What do you think?
I think that is easy and nice.
Nice, perfect.
Yeah.
Maybe not easy, but definitely nice.
Hmm.
So let's look at another question. Let's look at exponential equations and how logarithms tie. So I've already explained how you can use an exponentiation to solve a logarithmic equation, right? So raising a log to the same power, so sorry, I don't even know how to say this, but raising a log as a power of the number that is the base of the log will cancel it out, right? So for example, if you have log 3, raise it as a power of 3 and the 3 power will cancel out the log and give you x, right?
Yeah.
So this is a thing. And why is this a thing? Because logs and exponentials are opposite inverses of each other, so they cancel each other out. But we haven't seen a situation where a log cancels out an exponential instead, you know? Like we have an exponential equation and we try to solve it using logs. So let's try that out. Oh God. Here. Here's a situation. We have an exponential equation this time. So what do we do? As I said, a log and exponential, they're inverses. So obviously to somehow somehow bring these variables out from the exponent, we need to use logs. And you remember one thing I said was super, super important? I was like obsessing over it, this guy. The fact that
Yeah.
you can pull a power out front of a logarithm if it's inside. We're
Oh
going to use this
yeah.
idea.
Yeah.
what do you think I'm gonna do? So where could I start from?
You're gonna
I would need these guys to be inside a log to begin with to take the power out. So why not take the log on both sides? Why am I taking the natural log? I have no idea. It's just something that people do all the time, and I just started doing it too. In this question, they told you to do natural log, but you can actually take any log at all. Just make sure you take the same one on both sides. Okay?
okay.
It's just that calculators have a single button for natural log, I guess. There must be a technical reason for it, but I never bothered because I'm an engineer.
Wait,
So
why log of two? Could it be any log?
any log, yeah. That's what I was trying to say.
Oh, okay.
You can make the base anything. 2.5 for all I care, but natural log is, I guess, easiest to work with. Um, yeah, so this is what you do. The first step is take the natural log on both sides. Then, because of that very nice rule, you can pull that power out, which really defeats the whole point of an exponential equation, because now your variable is not in the power at all. So you've pulled it out, right? So all we gotta do now is just, I guess,
Yeah.
solve it. Remember, natural log of 3 is just a number, okay? Don't like treat it like a number. So we have x natural log of 3 plus
Okay.
natural log of 3 equals x natural log of 2 plus 3 natural log of 2. We can take all the numbers to one side and all the variables to the other. So I'll take this to the left side and I'm gonna subtract this on the right side. So far, so good. So this went
Yeah.
there, this went there. Are you
Okay.
following?
Yeah.
Okay. I think my voice is coming to you a bit late anyways. So now I can take an x common here, and on the right side I have that. And now I can divide both sides by this, and that's it, I think. Let me make sure. Yeah. So the answer is supposed to be in this specific form. How do we do that? How do we convert these guys to one logarithm? Okay. The first thing is we cannot do this. We cannot combine natural log of 2 and natural log of
You
3.
can't raise it back up, no?
No, no, no. Of course not. We have to combine them just using these rules. When you have additions and subtractions of logs, you use these rules, right? So how do we combine them? First of all, there's an issue. We cannot combine natural log of 2 and natural log of 3 here because they don't have the same coefficient. So maybe we can pull this coefficient into the log somehow. How do we do that?
Could we raise it?
hmm Natural log of 2 to the power of 3, which is 8. So far, so good.
Yeah.
Now, since we are subtracting two logs, we can divide the insides. Same thing down here. That is our answer.
Okay.
Okay, so what was the key? Key was when you have a pure exponential and a pure exponential on both sides of the equation, just log them. That'll remove the exponential part. Similarly, when you have pure logs on both sides of the equation, just cancel out the log parts. Okay,
All right.
okay, that's basically it. And yeah, so that's how you solve an exponential equation. Weird. So let's look at this one. So these are numerical questions directly. We don't need a calculator for this. I mean, calculator would be too easy. So the first one is log base 2 of 1 over 16. The question is, what do I raise 2 to get 1 over 16? What do you think?
Wallah, I don't know.
So let's start with the fact that we would need it to be a negative number, right? The power of 2 must be negative because it's 1 over something, correct?
Yeah.
Okay. Secondly, how do you get 16 from 2? What power of 2 is 16?
4.
That's it. Answer is minus 4. 2 to the power of
That's
minus
it?
4 is 16. Yeah.
Hmm.
You're just trying to figure out what you need to do to 2 to get 1 over 16. 1 over means it's negative. 4 because it's 16. 2 to the power of 4 is 16. And that's it. Easy peasy. So let me
Oh.
give you a similar question, similar difficulty. Log base 3 of 1 over 27. What is this going to be?
Hmm. Would it be -7?
Yeah, because 3 to the power of 7 is 27, isn't it?
No, leave me alone. Okay, wait.
So what is 3 squared, by the way?
9.
What is
So
3
it's 3
cubed?
cubed.
There you go. That's the answer.
Yeah.
Okay. It's okay. I'll let that slide. All right, we have log base 9 of 3 now. So what should I do to 9 to make it 3?
It's to the power of 1 over 2, right?
Nice. And finally, oh God, log base root 3 of 81. So what do I need to raise the square root of 3 to get 81?
I'm not sure.
So try to think about it. Let me pause the. So root 3 is 3 to the power 1 over 2, and 81 is 3 to the power 4. I need to raise 3 to the power 1 over 2 to something that makes it equal to 81, which is 3 to the power 4. So let's start by simplifying this. What is this? What happens when you
Um,
raise a power to another power?
it's multiplied, no?
So we have 3 to the power of 1 over 2x. Now, this is a special case of exponential equations. Of course, I could take natural logs on both sides also and solve this, because this is an exponential equation. But in this specific case, since the bases are the same, we can directly claim that 1 over 2x must be equal to 4. Because if
Is it
you
8?
raise, yeah, exactly, x is 8, which means that this is equal to 8.
Yeah.
Okay. It's also easy to think about it logically. If you know that 3 to the power of 4 is 81, root of 3 is essentially half a 3, right? So if you need to raise 3 to 4 powers to get 81, half a 3 must be raised to 8 powers to get 81, isn't it?
Yeah.
Because it's half a 3. Okay, so that's basically the answer here. Let's look at this one now. It's given that log of base a times b is of a equals 3. Show that show that log base ab of b is equal to -2. How do we do that? Can you write this down as an exponential equation first? Using the little circle thingy that we do. This one.
Which one?
You know how we say that a to the power ab to the power whatever. So say that as an equation. So for example, okay, go for it. Nah, exactly. Perfect. Be careful. It's ab to the power of 3, not a times b to the power of 3.
Oh my
Like
god, I
both of
forgot to
them.
put brackets.
hmm So we have that, which means that essentially a cube b cube equals a, correct?
Yeah.
Perfect. Um, okay, okay. So this is what the information given to us means, right? This is what we've been told basically from here.
Yeah.
Okay. Now we're trying to prove that log base AB of B is -2. Okay. So they're essentially claiming that if you take AB and you raise it to the power of -2, you will get B, correct?
Mm-hmm.
Okay. The only information we have to work with is this, and we're trying to prove this. Let's write this down. First of all, this means 1 over a square b square equals b. Okay. Which means if I multiply both sides by a square b square, I will get a square b cubed, which means that this is what we're trying to prove essentially, correct?
Okay.
So this is equivalent to this, that is equivalent to this, and that is equivalent to that. Because I've only done algebraic things, so I haven't done anything illegal so far, right?
Yeah.
Okay, this is what I'm trying to show. Using what? Using the only thing I have. A cube, b cube equals a. What do you suggest? How do I make this equation, the one that I know is true, somehow prove that this is also true? What can I do? So this is the only thing I can use to show that. Is there any algebraic step I can take to make this look the same as that?
Mm.
I'm not writing the answer, by the way. I'm just writing it a bit cleaner.
You can't do simultaneous equations for this, no?
No, no. I can't use both of these equations. That
All
would
right.
be philosophical anomaly because if I use the thing I'm trying to prove to show that it's true, then that's not really fair, is it?
Can
I
you
can
change the
only
one?
no, you can't touch this equation. All you can do is touch this equation in some way to make it look like that. That's all I'm allowed to do. So I want a 1 over here, and I want an a squared over here, essentially. Can I divide both sides by something to make that happen?
Give me a moment.
Mhm.
Oh, you can divide it by A.
Exactly. If I divide both sides by a, it will automatically prove that just because a is equal to a cubed b cubed, 1 must also be equal to a squared b cubed, which is very obvious actually. Okay. However, the trick was converting the logs into actual equations and then comparing those equations with each other. Okay. That was the trick to this question. A bit of a tough one. Hence, find the value of log base ab of cube root of a over square root of b. Let's write down what we have. So I'm just going to say a to the power 1 over 3 or b to the power 1 over 2. That's basically what they want us to find the value of, right? Sheesh. And all we know is that, okay, what do we know? We know that log base AB of A is 3, I think. Yeah. And log base AB of B is negative 2. So these are the things we know, and this is the thing we're trying to find. Okay. Now, the first thing I'll do is I'll write this log down as two separate logs that are being subtracted from each other because it's the same thing, isn't it?
Yeah.
Okay. Now we have this. Now, so the thing is, oh, that's b to the power 1 over 2. Okay. Now, can I somehow, like the thing is, I know what log base AB of A is, but I don't know what log base AB of A to the power 1 over 3 is. So could I get rid of this 1 over 3 somehow?
You could bring it down, no?
Hmm. And same thing here. I'll bring the 1 over 2 down. Oh, B. And now this is fun because I know exactly what this guy is and I know exactly what this guy is, don't I?
Yeah.
So I can replace the log base AB of A with 3 and the log base AB of B with negative 2, which leaves me with 1 plus 1. Answer is 2. Boom. That's it.
Okay.
So this question was a bit tough, honestly, especially this first part. However, the second part, even though it looks difficult, is very common. Okay? You're
Which
given a
part?
fraction, so this part basically. The this part was tough and kind of new also. Okay? This is a bit
Mm.
interesting. However, this is common, happens all the time. They give you a log, and inside the log you have a division of two things or a multiplication of two things, and you have to realize that you can break it down into a sum or subtraction of two separate logs. Okay,
Okay.
so this step was the key, and this is common, this step. Does the question make sense?
Yeah.
Perfect.
I think